Alright, so in this program is a circuit which is consists a voltage source 15 volt and a resistor and a portion of that wire. Some portion of this wire inside a magnetic field which is 50 millitesla. Now we have to find out the magnitude and the direction of the net force on this circuit which is inside that magnetic field. To find out that force on that one, we have to find out that three segment we can define over here. Say I can use the different colors. Say that this is the segment 1. Say this is the segment 1. This is another segment, is segment 2, and this is say the segment 3. I'm considering say this segment is length is x. I don't know what is that, but I know that segment is say that L, which is L is 10 centimeter is given. Fine. I also choose say this is the positive x direction. I'm saying this is the I hat, this is the positive y direction, and say out of the screen is positive k hat, so that's when it is that z direction. I'm using that reference axis over here. Now the current into that circuit, we can find out when its current is going to that part, it will create some force onto that segment of the wire, right? We can find out that force using that formula. Force on a wire is a magnetic force. Actually we can write using that formula, current into that wire into L cross B. B is the magnetic field and N is the length. We'll use that portion over here to find out that forces on that segment. Fine. For the first segment, and we'll also use that right hand rule to find out that forces over here, the direction of the force. So what we'll do, we'll put our index finger in the first vector, so that's the direction of this length, and the palm is into that second vector. Then we'll rotate that one, right? So if we do that, then the forces on the segment 1, I can say this is the force which should be towards that direction, this is upward. We can find out mathematically also, we'll do that. So this is the force on 1. If you say this is to be that force on that segment 3, we'll use the right hand rule also over here, and this will be the force on segment 2 towards that rightward direction. And we have to find out resultant of these three forces over here. Then we can say that the net force would be sum of these forces, right? So force on segment 1 plus force on segment 2 plus force on segment 3. So this is to be my resultant force over here, right? Fine. First I have to find out the current into the circuit. That we could find out using that Ohm law, right? V equal to IR. Then we can say that I would be V over R, which is 15 by 3. That is going to be 5 ampere. So that means I into the circuit is 5 ampere. Fine. Now I'm going to find out that F1 first. So I'm going to find out that F1 would be that current is the same, because in series, right, I into X I hat, right? So this is the length which is towards the positive X direction according to my this reference axis, cross the magnetic field over there, which is into the base. I should write minus B into K hat, because I choose the out of the screen actually the positive Z direction or positive K hat, then into the screen would be the negative K hat. Since the magnetic field actually over here into the screen, so that's why it will be the minus B K hat. Now we can simplify this one. What would be that? We can write F1 would be, I can factor out this minus sign, minus I B X into I cross K. Now you can use the properties of the unit vector. So I, Z and the K hat is a I cross K, which is, I mean, I'm moving towards the clockwise direction. We know that if we move to the counterclockwise with the positive, if we move to the clockwise is with the negative. Then I cross K is going to be that minus J, right? Then I will find out this F1 is going to be the minus I B X is going to be the minus J hat. That will give me actually that F1 would be this minus one is going to the plus, is going to the I B X into J hat, right? So that means it should be towards the positive Y direction. I draw that one, which is, this is my F1, right? This is the F1 which is towards the positive Y direction. I use that right hand rule. I put my index finger towards the direction of the X and I keep my palm into the screen, then I rotate rest of the finger towards the second vector, that means towards the screen. Then my thumb is upward direction, so that's why I find out this F1 will be towards that positive Y or Z direction. So I can also find out that mathematically. Fine. Now F2 I can write, so F2 would be I into L. F2L is basically this one, right? This L over here, you can write this L would be minus, I can write L is basically the minus L into Z hat, because the L is towards the downward, cross B actually that minus B K hat, right? So this is actually that L which is towards the negative Y direction, so that's why I use that minus J. Fine. What would be that case? So F2 is going to be, in that case, this minus is going to plus I into L into B is going to be that J cross K. If I do that, what is the J cross K? J cross K for this one, right? I'm going to find out, I'm going to the counterclockwise over here, right? J cross K is going to be that plus I. J cross K is going to be that, I'm moving to the counterclockwise, this will be the plus I. Then I will find out this will be the I, L, B would be I hat. So that's when it should be towards that positive X direction. I can use that also, that right hand rule. What I'll do, I'll put my index finger towards downward and I will keep my palm into the screen. Then if I rotate my rest of the finger towards that second vector, that's mean into the screen, I'll find out my thumb would be towards that direction. I'll find out my thumb would be towards that direction. So that's why this is will be that also that direction of the F2. I can also find out this mathematically. Fine. So this is would be my F2 is I L B I head. Fine. Now what about the F3? F3 I can write, so F3 would be I. Now for the F3, this is my segment, right? So this is my segment over here, and this is actually towards that negative X direction is the X. So then I'll write this would be minus X I head cross minus B A head. B is into the screen. Then I'll find out this F3 would be this minus minus going to the plus I X into B into I cross K. Now what will be that I cross K? This is I, J and K. I cross K. I cross K, this one, right? I cross K is going to the minus J. Then I will find out this F3 is basically I X B. I cross K is going to be basically that minus J. So that's mean I'll find out that F3 would be minus I B X Z head. So this is my F3. Now I'm going to add them together to find out that resultant force or the net force. So that net force, if net would be I B X J head, which is the F1, plus I B L I head, plus F3. F3 is the minus I B X Z head. Now this will be the cancel out, right? You can say I'm using the different color. This one F1 and F3 is going to cancel out, right? You can also find out that figure because this F1 is towards the upward direction, this F3 is towards the downward direction because they are in the same length and same current. So the force on these two segments will be the same. They will be cancelled out. So then I'll find out the resultant force would be only provided by the segment 3. Sorry. So then I'll find out this F net would be basically I B L into I head. I know that everything, right? The net force will be towards that positive X direction. So if you plug in that value of I, which is the 5, and that magnitude of this magnetic field, which is basically 50 millitesla, right? That's given. So V is 50 millitesla, 50 into 10 to the minus 3, and the length is the 10 centimeter, so which is 10 into 10 to the minus 2 meter. Then you will find out that the net force on this circuit would be 2.5 into 10 to the minus 2 I head Newton. So that should be that force onto that wire. This is the answer of this question. Okay, thank you very much.